Hey guys, this video is designed to help you understand what a type 1 error is, type 2 error, and power. So let's jump right into it. In the previous video, I made a video about Z-tests, and in the Z-test, we were given this example where a CEO was trying to see how much time his employees were spending on the computer surfing the web, and we found that he was trying to prove that they were spending less than 120 minutes, and you had to graph this data. So if you want, go back and watch that Z-test video, so you can see the distribution of this data. And this distribution turned out to be skewed right. And because the distribution was skewed right, we had to assume that it was an approximately normal distribution, and then we said we were going to proceed with caution. Well, that means that perhaps our answer isn't as accurate as it could have been, our decision. Perhaps our decision is false because our conditions didn't pass. Therefore, we might have created errors. So let's look at the different types of errors. We drew this little table in class, and I just want to make sure you understand this table. So these are the two options you would get based on your hypothesis test. So you either, so ignore this right now. On your hypothesis test, you're either going to get reject H0 or fail to reject H0. P is less than alpha, P is greater than alpha. Okay, and let's say somehow the CEO could go online and see what everybody in the company, how much time they're spending on the internet. So somehow somebody knows the truth. So this is what's true, but you were hired to answer this based on the 10 people that you interviewed. So if you reject H0, you want H0 to be false. Or I think in class we wrote HA is true. I think that's how we wrote it in class. So if you reject H0, you want HA to be true. That means you made the correct decision. You correctly rejected the null hypothesis. If you reject H0, but H0 is really true, that's called a type 1 error. That doesn't mean you did your math wrong. It just means that you did not make the right decision based on the data you were given. Okay, if we fail to reject H0 and H0 is true, we've made a correct decision. And if we fail to reject and HA is true, that's called the type 2 error. So these are the types of errors. And we want to reduce those because we don't want large errors. We want this to be large. And the probability of this occurring is called power. And we'll get to that in a second. So the definition of type 1 error is when you reject H0. Remember, you're rejecting H0 based on your Z-test or your 1-prop Z-test or your 2-prop Z-test, but then somehow you found out information about the population, but really H0 is true. Type 2 is when you fail to reject H0, but somehow you found information about the population and you realize that HA is true. Okay, so let's look at that example about the CEO again. In that problem, we set mu equals to 120, and mu is less than 120 was the claim, that the CEO claimed that less than 120 minutes were spent online. So if I'm going to reject H0, so let's just start there. When you're finished with the test, you're going to say that you have significant evidence that the true mean time spent surfing the web is less than 120 minutes. So I'm just going to be a little less formal here and say, I believe time spent online is less than 120 minutes. Okay, so this is what you think happened, but then you found out something about the truth. But really, I believe the time spent online is less than 120 minutes, but really, you really shouldn't say it is 120 minutes. You really should say that it is not less than 120, but that's fine for what we're doing. But really, it is, time spent is 120 minutes. Okay? So let's see, what would be a consequence of this? I believe the time spent online is less than 120 minutes, but really it's 120. So a consequence of this could be less productivity at the office. Like people are spending, like the boss thinks that they're not on the computer messing around all day long, but really they are. So, you know, less productivity is probably the worst consequence there. Okay, let's look at this one. A type 2 error is where you fail to reject H naught. So I believe the time spent online is 120 minutes. Okay, so that's what you thought after you did your Z-test, that's what you got. But then somehow you found information about the truth. But really, time spent is less than 120 minutes. So a consequence of this might be, I don't know, I believe time spent is 120 minutes. The boss gets mad and yells at all his employees because he's like, you're spending too much time on the computer, but really they're not. And so you've got disgruntled employees. So, and then which one do you think is worse? And really that's just your opinion. And sometimes the question's a little bit more obvious which one's worse. All right. So when you guys write these out for a free response, I always write down the definition first, and then I dissect the definition and write one sentence at a time, like I did here, reject H naught, and then I wrote down what reject H naught means. And then I write down the second half of the definition, and I think that makes it a little easier when you're trying to write type 1 and type 2 errors. Okay, so let's look at the probability of these errors occurring. The probability of a type 1 error is alpha. We've seen that. That's our significance level. So we're really used to seeing that. Remember, that's just a number that you've arbitrarily chosen to be that standard, that anything below that number can occur. So this is a this is the probability of a type 1 error occurring. The probability of a type 2 error occurring is a new variable we call beta. Now you won't have to calculate beta for the AP test or for this next upcoming class test. You just need to know that this one's type 1 and this one's type 2. All right? So the probability of this occurring is alpha. The probability of this occurring is beta. But remember, we said this is the good one. This is what we want to happen. Okay? We call that power. And power is calculated by doing 1 minus beta. So let's look at the exact definition of power. Power is the probability of rejecting the null hypothesis when the null hypothesis is true. So in shorthand, it's the probability of making that correct decision. I said true, I meant false. Sorry, it's getting late. So the probability of rejecting H naught when H naught is false. So the probability that your Z-test or 1-prop Z-test or 2-prop Z-test correctly made the right decision. Okay? So you always want to be right. So let's find ways to increase power. So one way to increase power would be to increase sample size. So one way to increase power is to increase sample size. And the reason that would increase the power is your sampling distribution is going to become thinner, kind of, and taller. So what that means is it's going to get closer to the true parameter. So it's going to become more accurate. So your decisions are going to be better. Another way to do it is to increase alpha. By increasing alpha, you are increasing, so for instance, let's say you had a p-value of 0.065 and you had an alpha. Well, that's fail to reject. So if I want to reject, let's increase the alpha so that way this goes in the other direction. So if I increase the alpha maybe to 10%, now I went from fail to reject to reject. So increasing the alpha increases the power. Okay, so here are 2 examples. Let's go through them and hopefully that'll help. So we're going to start off, let's say we did the test, the CEO surfing online test at alpha is 0.02 with a sample size of 100. You do the whole test, but then you say, you know what, I'm going to change that alpha to 0.05. What effect is it going to have on all these probabilities? Okay, so right away we see that the alpha increased. And alpha is the probability of a type 1 error. So we know that this probability will increase. We also said over here that if you increase alpha, it increases power. So we know that this probability will increase. And these two are, remember that this one is alpha, this one is beta, and this is 1 minus beta. So these are complements of each other. So if this number goes up, this number has to go down. Okay, so now why don't you stop the video, try this one, and then turn it back on and see if we got the same answer. Okay, so in this problem we went from alpha of 0.04, a sample size of 100, and then this time we're going to change the sample size and leave the alpha alone. So since we didn't change the alpha stayed exactly the same, the probability is going to stay the same. All right. We increased the sample size from 100 to 300, and we said right here that increasing the sample size increases the power. So this probability will increase. And these are complements of each other. So this probability will decrease. All right. So hopefully that explains type 1 error, type 2 error, and power, and good luck studying for this test.